Hello, hope everyone is well. The first lecture is going to be on finding the particular solution to non-homogenous second order differential equations. Okay, so the first thing we do is, step 1, we find our auxiliary equation. Just like we did when finding the solutions to homogeneous differential equation. And 2, we're going to factorise the auxiliary equation, or use a quadratic formula. Okay, now 3, decide which case we have. Okay, remember case 1. If we factorise it, we've got 2 different real roots. Then our complementary function is y equals ae to the power of m1x plus be to the power of m2x. Okay. Case 2, is if we've got 2 equal or 2 roots that are the same. Our complementary function that we use is y equals ae to the power of m1x plus bxe to the power of m2x. But remember, m1 and m2 are going to be the same thing. And finally, case 3, and this is when we cannot factorise, so we're going to have to use a quadratic formula. And that is when we have complex roots, i.e. m is equal to p plus or minus jq. In that case, our complementary function is y equals e to the power of px a cos qx plus b sin qx. Okay, then 4, use the right hand side of our original equation, or our differential equation, to decide what our trial function for our particular integral should be. So decide what our trial function should be. Okay, now I have put onto Teams the particular integral table, or the trial function table. It looks exactly like that. So the right hand side of your differential equation decides what our trial function should be. So if the right hand side of your differential equation here is just a number, we just choose c. Y equals c is our trial function. If the right hand side of our differential equation is just a linear thing, so it's just got an x in it and maybe a number, or just an x in it, we use cx plus d. If the right hand side of our equation is a quadratic, 4x squared plus 7x plus 9, or 5x squared plus 2, anything that's got an x squared in it, use cx squared plus dx plus e. Similarly, if it's got a cubic in it. Now, if the right hand side of our differential equation is an exponential, all we do is we use this format here. And lastly, if it's either a sin or a cos, then we've got to use sin and cos in our trial function. And the number in front of the x should stay the same in both parts of our trial function. So we choose our trial function, and then step 5, differentiate the trial function twice, and substitute into our original differential equation. Okay. We equate coefficients. To find the values of the constants in the trial function. And this gives us our particular integral. And remember that your general solution is y equals your complementary function plus what you get for your particular integral or your trial function. So this bit here is your particular integral. Okay? So that is the first 7 steps. So that's what we would be doing and what we did last week when we wanted to find the general solution. Okay? But we are not looking to find the general solution here. We are looking to find the particular solution. Okay, so to find the particular solution, the final few steps are step 8. We differentiate the general solution and we substitute in our initial conditions and then solve to find the values of A and B. Okay, so it's a 10-step process, and you'll see from the examples that I'm going to do that these questions are worth a lot of marks. Again, I've put the worksheet up on Teams. You can see that one question is worth 14, one question is worth 16, and the other question is worth 12 marks. So that'll give you an indication of how difficult the questions are. Okay, so we've got our process, 10-step process. Feel free to, I'll put these notes up on Teams once I've done it. So 10 steps. It's all to do with, first, choosing the correct case, then choosing the correct trial function, and then it's basically just simultaneous equations with a little bit of differentiation thrown in there. So just like I said to you before, Engineering Maths 5, it's not any more difficult, there's just a lot more processes for us to follow. So let's look at example number 1. And it's going to say, and find a particular solution. You can also say the unique solution, it means the same thing. To t squared y by dx squared plus 5 dy by dx plus 6y equals 12x squared plus 2x is equal to 5. So that's my first example. Right now, because I'm looking to find the particular solution, I need initial conditions. So the question needs to provide me with these. So the initial condition is when x equals 0, y equals negative 6, and dy by dx equals 3. So that means I now have all the information I need in order to proceed with this question. Okay, so the first thing I'm going to do is I'm going to pretend it's a homogeneous differential equation and set out an auxiliary equation. Okay, so that's m squared plus 5m plus 6 is equal to 0. And all we need to do is our usual factorising, which we know is we look for common factor, difference of two squares, and trinomial. But I know from looking at that, it's got three terms. It's not going to be either of these, so it's a trinomial. And that's when we do add and multiply. If you want to, in all these questions, you can use the quadratic formula. It's not a problem. It takes a lot longer, but you will get the same answer in the long run, so it's completely up to you what you decide to do. So that means I'm adding to make 5, multiplying to make 6. All the ways of making 6, 1 times 6, 2 times 3. Well, which pair adds to give me 5? Well, 1 plus 6 is 7, so it's not that. 2 plus 3 is 5, so 2 plus 3, and they're both positive. So that's n plus 2, n plus 3 is equal to 0. So that tells me that m plus 2 equals 0. So m is negative 2. And this one here, m plus 3 is equal to 0. So m is negative 3. Okay, so now I've got to decide which case do I have. So if I go back to my 3 cases, which I've written down here. Okay, so case 1 is 2 different real roots. Case 2, 2 roots that are the same, so the same number twice. In case 3 is when we've got complex roots, and if I'd use the quadratic formula. So no, it's not case 3. Case 2, it's not that because the numbers are both different. Okay, I've got negative 2 and negative 3. They're different numbers. So that means it's case number 1. So that means that my complementary function, which was what we called the general solution when it was a homogeneous differential equation, is just y equals ae to the power of negative 2x plus be to the power of negative 3x. And that's the first bit of my differential equation done. Now, next step is I need to find out the particular integral. So the first thing I have to do is choose the correct trial function. So to do that, I get my table up. So hopefully you're able to look at that on Teams, but I'll just put it up on the screen just now. So these are the list of my trial functions. Okay, and which one I use is dictated by the right hand side and the start of my differential equation. So if I see here, this is a quadratic. It's got an x squared in it. Doesn't matter about the rest of it. It's got an x squared in it. That means it's a quadratic. So if I look for quadratics, I use cx squared plus dx plus e. So that's what I'm going to choose my trial function to be. So it's y equals cx squared plus dx plus e. Now remember, and this is the bit that people struggled with when we're doing general solutions, that c, d and e are just numbers. So you just imagine c is 2, d is 3, e is 4, something like that, and differentiate it as if that's what's happening. So dy by dx. So if that was 2x squared, the 2 would come down to the front and make it 4. So here it's going to be 2cx. If that was 2x, it would just become 2. So dx just becomes d. And if e is just a number, you differentiate a number, you just get 0, so it goes away. And then I need to differentiate it again. So again, 2, a number times x, well, you differentiate that, you just get whatever the number is. If I differentiate a number, I get 0. So those are my my y, my dy by dx, and my d squared y by dx squared. So I now have all 3 things. And what I'm going to do is I'm going to substitute those into my original differential equation up the top. Okay, so I'll write down my original differential equation to start off with, and then substitute in. So d squared y by dx squared plus 5 dy by dx plus 6y equals 12x squared plus 2x take away 5. So 2c plus 5 times 2cx plus d plus 6 times cx squared plus dx plus e equals 12x squared plus 2x, take away 5. And hopefully you can see all that on the screen there, right? So I've substituted in the d squared y by dx squared in here, so that's 2c. The dy by dx is 2cx plus d, so I just put that in place. And finally the y is cx squared plus dx plus c. So I've just substituted that in as well. Okay, so next step, what we're going to do is, we are going to multiply out that bracket and equate coefficients. So, 2c plus 10 cx plus 5d plus 6 cx squared plus 6 dx plus 6e equals 12x squared plus 2x, take away 5. Okay, and we're just going to equate coefficients. And we equated coefficients in partial fractions, we equated coefficients lots and lots of times before. Okay, so what we're looking for is the term, we've got x squareds, so that's the highest power term, so we're going to equate those first, so x squareds. Okay, and we're going to look and see what we've got on the left hand side of the equation and what we've got on the right hand side of the equation. So in front of x squared, in the left hand side of the equation, I've got 6c. And in front of x squared, on the right hand side of the equation, I've got 12. So I've equated my coefficients. So that just tells me that c is 12 divided by 6. So that just tells me that c is 2. Right, and I'll try and keep these letters down the side so that we can see what's going on. And it's easier to write an answer down at the end. Right, we're now going to look at x's. And again, all you're doing is looking for the numbers that appear in front, or the number and letter that appears in front of x on both sides of the equation. So I've got 10c of them here and 60 of them here. And I'm told that that is equal to 2 of them on this side here. So I'm all good. But I've got 2 letters here. And I really want to know what d is. But I know the first thing that I've worked out is that c is equal to 2. 10 times 2 plus 60 equals 2. So 20 plus 60 is equal to 2. So we're going to take the 20 across, and obviously that becomes a subtract. So we've just got to divide by 6. So again, that tells me that d is equal to negative 3. So I'm nearly there. I've worked out what c is, I've worked out what d is, and in my particular integral it was cx squared plus dx plus e, so that means I've still got to work out what e is. So I'm just going to look at constant terms or number terms. Okay? So those are things that don't have x's in them. So if I look in the left hand side of my equation, I get 2c plus 5d plus 6e, and that is equal to negative 5. So constant terms, so terms that do not have a letter in them, because we've worked out our x squareds, our x's, and now we just look at our constant or our number terms. Okay, again, we know what c is, we know what d is, so we're just going to substitute those in. So 2 times 2 plus 5 times negative 3 plus 6e is equal to negative 5. So we work that as that's 4, take away 15, plus 6e equal to negative 5. So negative 11 plus 6e is equal to negative 5. So again, I'm going to move my negative 11 over, so it becomes an add. So 6e is equal to negative 5 add 11, which is going to be 6. So e is just 6 over 6. So nicely, e is just 1. Okay, so what I've done is I've set out my particular integral, my trial function, which was cx squared plus dx plus e, and I've worked out over the course of the last page that c in that function is in fact 2, d in that function is -3, and e in that function is 1. So that means that my particular integral pi was cx squared plus dx plus e. That was my trial function. It all worked out, and it told me that c is 2, d is -3, and e is 1. So our particular integral is 2x squared take out 3x plus 1. And remember, a general solution is what we get when you add the complementary function and that particular integral together. So you go back to your first page, your solution. It was one of the first things we did. We worked out our complementary function, and that was ae to the power of -2x plus be to the power of -3x, and then all we do is we add our particular integral to the end. So that's 2x squared take with 3x plus 1. So that's my general solution there. And for that I would be looking at probably 10 marks if I got that far. Now, remembering, I don't want the general solution, I want the particular solution. So that means I want to work out what both a and b are. I don't want any constants at all, or any letters apart from y and x in my final solution. So I've got these initial conditions that were in the question. And the initial conditions I was given is when x equals 0, y equals -6. And when x equals 0, dy by dx equals 3. Now, I know what y is. Y is ae to the power of -2x plus be to the power of -3x plus 2x squared take away 3x plus 1. So I can substitute in x equals 0 and y equals 6 to that general solution. However, my other initial condition is involving dy by dx. So that means I need to differentiate this general solution here. Now, differentiating this is quite easy. There's no product rule, there's nothing like that. So all we need to do is differentiate the exponentials. So dy by dx is -2ae to the power of -2x take away 3b e to the power of -3x plus 4x take away 3. Remember, if you differentiate an exponential, the power just jumps out to the front because of the chain rule. Same here. If you differentiate 2x squared, the power comes down to the front and we multiply. And if you differentiate anything x, it just becomes the constant that's in front of it. If you differentiate a number, as we've already spoken about, it becomes 0. Right, so our first initial condition was when x equals 0, y equals -6. Okay, so that means we're using this equation here, because that's the equation for y. So that means that -6 equals ae to the power of 0, so I'm just putting 0 in here, plus be to the power of 0, plus 2 times 0 squared, which is 0, take away 3 times 0, which is 0, plus 1. Now, people have got an awful habit of when they're doing this type of question, is when they're substituting in 0, they just let everything here just become 0. Remember, if you've got a number there, that number is staying the way it is. Now, remember that e to the power of 0 is 1. Anything to the power of 0 is just 1. So that means that just becomes a, that just becomes b, that's 0, that's 0, plus 1. So that means that -7 equals a plus b plus 1. And then I'm just going to move that 1 over, so -7 equals a plus b. Now, I know I'm going to have to use simultaneous equations, right? It's a certainty. So what I'm going to do is I'm just going to move a or b across, so I've got a equals or b equals. So So I'm just going to move that b across to a equals negative 7 take away b. You could do the simultaneous equations using elimination from National 5, but I think this is maybe a little bit easier. Okay, so our second, so hopefully you've all got that there. So you've just substituted y equals negative 6 in place of y, and x equals 0 in place of all of your x's in that y equation there. So the second initial condition is when x equals 0, dy by dx equals 3. So this time we're using this equation here, because this equation has dy by dx in it. So we're going to swap dy by dx for 3, and we're going to swap all our x's again for 0. So 3 equals negative 2a e to the power of 0, take away 3b e to the power of 0, plus 0, take away 3. Again, 2 times 0 is 0, 3 times 0 is 0, 4 times 0 is 0. So I'm just kind of shortcutting and just making everything work a little bit more easily. So that means that 3 equals negative 2a, take away 3b, take away 3. And again, I'll just move that negative 3 over, so 6 equals negative 2a, take away 3b. Okay, now, earlier on, I've worked out that a is the same as negative 7 take away b, so I'm just going to substitute that in place of a. So that means that 6 equals 14 plus 2b take away 3b. Just like that. Okay, so I'm just going to move the page up. So 6 equals 14 take away b. So I'm just going to move that 14 over. So that means I've got negative 8 equals negative b. So b is just 8. And again, I'm just going to work out a, but I'll just use this equation here. So negative 7 take away b equals a. So negative 7 take away 8 equals a. So negative 15 equals a. So I've got my two values of a and b. So all I've got to do is substitute that back into the general solution. So my general solution, if we remember, is this thing here. Okay, general solution here. Now I know what a is, now I know what b is. So your particular solution is y equals negative 15 e to the power of negative 2x plus 8 e to the power of negative 3x plus 2x squared take away 3x plus 1. Again, I know it's getting a little bit bright for you to see. There's a little bit of glare off the paper, but is the best we can do at the moment. So that is your final solution to that, and that would be a question probably worth about 14 marks if it was given to you in the final exam. So 3 pages are working, but as I said, nothing is got more difficult. There's just more decisions to make and just more processes to follow. So that's example number 1. Right. I'm now going to look at example number 2. Right, and example number 2, we're looking at we're going to use a sin and a cos one this time, just to show you the difference. I'm also going to choose a different case. I'm not going to choose case 1 because we've done lots of ones that are case 1. So I'm just going to change the wording to find a unique solution to just to d squared y by dt squared plus 4 dy by dt plus 4y equals negative 100 sin 4t. Now, as you can see, I've changed the wording. Particular has become unique. Particular and unique mean the same thing. But what I've also done is, rather than using dy by dx, like we use all the time, I've changed it so it's become dy by dt. But nothing has changed. It's always the same thing. Wherever you see a t, you put x or whatever, and you think about it just exactly the same way as we've been doing before. Now, again, we need initial conditions, and again, I'm going to give them in a slightly different way, just because that is what happens in maths. Use different terminology for different things. And again, all that means is when x is 0, y is 2, and when x is 0, dy by dx, or y dashed, is equal to 6. So it means the same thing. Nothing has changed apart from the fact we're going to be using t's in place of x's. But let's see what happens. So, first thing again, we set up our auxiliary equation. So that's m squared plus 4m plus 4 is equal to 0. And again, we're wanting to factorise that again, or use the quadratic formula. It's a trinomial. So again, add and multiply. So I'm adding to make positive 4 and multiplying to make positive 4. So in order for me to do that, now I've got 1 times 4 and 2 times 2. Well, 1 plus 4 is 5, 2 plus 2 is 4, so it's that one there, and they both need to be positive because it's the only way that that's going to work. Okay, so I've got m plus 2 equals 0. So m plus 2 equals 0 and m plus 2 equals 0. So that means negative 2 and negative 2. So this is the point where we have to make a key decision like we did in the last question. So you go back to the process that I gave you, the 10 steps, and if you look at our cases again, well, this time the roots aren't exactly the same. Okay, so that means we're going to be using this form here, which is exactly the same apart from getting x in here. But obviously we are not using x's, we are using t's. So that means our complementary function is y equals ae to the negative 2t plus bt e to the power of negative 2t. So that is the complementary function to my differential equation. Right, so next thing, we need to find our particular integral. So again, we need to find our trial function. So complementary function, and as I said, I should have said that was case number 2. We decided that was. And if you write that down, it means if you go back and you can check that you've done everything right. So trial function, remember the trial function is dictated to by the right hand side of your differential equation. So the right hand side of your differential equation tells you what to do. So if I look at my table, so this is my table here. So the right hand side of my differential equation is something sine 4t. So if I look at if I've got 4 sine 2x, I choose c sine 2x plus d cos 2x. Right, so rather than 2, I've got 4. So I'm going to be using c sine 4t plus d cos 4t. because whatever the number is in front of, the x or the t stays the same, and it goes in both parts of our trial function. So it's y equals c sine 4t plus d cos 4t, right? And this bit is annoying, right? There's quite a lot of different things to do, so you've got to differentiate, right? So you're going to differentiate once, so that gives me 4c cos 4t, and watch your c's and your cos's. If you think you're going to have c's and cos's mixed up, use d and e as your values in the trial function, or two random letters. It doesn't need to be c and d. And remember, if you differentiate cos, it becomes negative sine, so it's going to be negative 4d sine 4t. Right, differentiate it again. Okay, again. So sine became cos, cos became negative sine, so cos becomes negative sine again, and remember the 4 jumps out, so that's negative 16c cos 4t. Sine becomes normal cos, that's staying as a negative, so it's negative 16d sine 4t. And now what we're doing is we're going to substitute that back into our original differential equation at the top. Okay, we're going to put those two functions back into our original differential equation. So again, I'm going to write down the differential equation and substitute in the values. So d squared y by dx squared. Oh, I've started using x. Remember your x's should be t's. That's my mistake. Make sure you fix that. So it should be d squared y by dt squared. Right, plus 4 dy by dt plus 4y equals negative 100 sine 4t. Okay, so as I was saying before, we're going to substitute those values in. So I'm going to put them in brackets. So negative 16c cos 4t take away 16d sine 4t plus 4c cos 4t take away 4d sine 4t. It's going to go on forever. Plus 4c sine 4t plus d cos 4t equals negative 100 sine 4t. So again, exact same thing as before. So I've swapped d squared y by dt squared for my d squared y by dt squared. I've swapped my dy by dt for my dy by dt. I've swapped my y for my y. I've just substituted it all in. So now you've got to go through the process of multiplying out all these brackets. Now remembering, watch your c's, they're not brackets. Okay, so I've got negative 16c cos 4t take away 16d sine 4t plus 16c cos 4t take away 16d sine 4t plus 4c sine 4t oops, another mistake I have spotted. Right, so see our second derivative, that should have changed to sine, and that should have changed to cos. Apologies for that, I missed that out when I was doing that. So again, that should be, that's fine, that should be sin, and that should be cos. Apologies for that. Okay, let me just start that a little bit again. So I've got negative 16c sine 4t take away 16d cos 4t plus 16c cos 4t, take away 16d sin 4t plus 4c sin 4t plus 4d cos 4t equals negative 100 sin 4t. Okay, so I've just multiplied out that bracket, or those sets of brackets. Now what you can see is, and it will be the same as the one in the worksheet, is that you've got c sin 4t and d cos 4t, and you can actually collect like terms there. So it's negative 12c sin 4t, take away 12d cos 4t plus 16c cos 4t, take away 16d sin 4t equals negative 100 sin 4t. Right, now again we're going to equate coefficients, but it looks a lot different to the coefficients, or the equation that we're equating earlier on with x squareds and x's and numbers. But again, look at what your numbers in your letters are in front of. Those are, your coefficients are c, d, c and d. So your functions are sin 4t and cos 4t. So that's the two functions we're going to be equating each side. So in front of sin 4t, on the left hand side, get negative 12c, take away 16d, and on the right hand side I've got negative 100. Okay? Look at cos 4t. We'll do something with that later on. So we've got negative 12d plus 16c equals 0. Okay, now this is going to be the easier. This is going to be the easier equation to deal with. So I'm just going to say, right, 16c equals 12d. So c is 16d, or 12d over 16, both in the 4 times table. So that's 3/4 d. So I'm just going to substitute this. So I've just equated it, found out what c is in terms of d by using the second equation. I'm just going to plug that in place of c in that equation. So negative 12 times 3/4 d, take away 16 d is equal to negative 100. So that's negative 36 over 4d, take away 16d equals negative 100. So again, remember, if you're multiplying a fraction by a number outside, it's only the top of the fraction that multiplies. Negative 36 over 4 is negative 9, so it's negative 9d, take away 16d equals negative 100. Looks like it's going to give me a nice number, which is good. So negative 9d, take away 16d is negative 25d. And then all I need to do is divide. So d is number 4, which is quite nice. Okay, I was hoping it was going to give me a whole number. If it does, you normally know you've done it right. Obviously, questions aren't always that nice though. But again, we also know that c is 3/4 d. c is 3/4 times 4, so c is equal to 3. Okay, so we've just used our second simultaneous equation. So we've worked out that d is equal to 4 and that c is equal to 3. Okay, so then that means I can put that into my general solution. So my particular solution my general solution was y equals ae to the power of negative 2t plus bt e to the power of negative 2t sorry, this is my general solution plus, and it was the formula that I'd chosen was C, my trial function, C sin 4t plus d cos 4t, right? But I've worked out that C and D are 4 and 3, so I'm just going to put that in. So y equals ae to the power of negative 2t plus bt e to the power of negative 2t plus 3 sin 4t plus 4 cos 4t, right? So for this question, that's really tough. It's really tough to get down to general solution, and for me, if I was marking this, it would be worth 12 marks. So I need to find the particular solution. So again, I need to go and I need to look at what I was given in my initial conditions. So in my initial conditions, I know when x equals 0, y equals 2, and when x equals 0, dy by dx equals 6. So in the exact same way as I did last time, I'm going to have to differentiate this general solution that I've just worked out. But as I've said to you already, if you've got as far as the general solution, you've got the majority of the marks. So I'm going to differentiate this general solution now. Because it's case 2, I've got a product rule in here, because I've got a function with a t in it multiplying another function here with a t in it. This is going to be straightforward to differentiate, that's straightforward to differentiate, so is that. So this is my problem in here. Right, so I'm just going to differentiate that as normal, so that'll give me negative 2a e to the negative 2t. Now wherever you think there's a product rule, I'm going to put a bracket, so there's a bracket there so I can do my product rule. Right? So that there is the first part of my product rule, that there is the second part of my product rule. Okay, so if I differentiate that bit, I just get b, leave the second bit alone, like that. So differentiate that bit, get b, leave the second bit alone, plus the first bit left alone, times what you get if you differentiate the second bit, which is going to be negative 2e to the power of negative 2t. Okay, differentiate this, it's going to give me 12 cos 4t. And if I differentiate this, remember cos becomes negative sign, so it gives me negative 12 sin 4t. Right, so let's just put all that together. So negative 2e to the power of negative 2t plus be to the power of negative 2t, take away 2bt e to the power of 2t plus 12 cos 4t, take away 12 sin 4t. Remember that's dy by dx. So I've got my y, I've got my dy by dx, so I can use my initial conditions. And as we said in the question, so I've got my y, got my dy by dx, and these are my initial conditions. When x equals 0, y equals 2, and when x equals 0, dy by dx is equal to 6. So let's put that in. When x equals 0, y equals 2. Again, I just always write it like that. And remember, I'm using the y equation. That is the equation for y. My general solution is the one for y. So I'm going to be swapping y for 2. Sorry, it's not. It's going to be t. Because remember, we're dealing with t's. I need to make sure, keep on changing that. And if that comes up in the exam for you, make sure you're always swapping your x's for t's. Happens. Right. So, 2 equals ae to the power of 0 plus b0 e to the power of 0 plus 3 sine 0 plus 4 cos 0. So I've just substituted each of 0 in place of all my t's here and 2 in place of my y. Now we know e to the power of 0 is 1. So it's going to give me a. That 0 makes that bit go away, so it's going to be 0. Now sin 0 is 0 if you type it into your calculator, and cos 0 is 1. So that just gives me 4. So 2 equals a plus 4, so a is negative 2. Just put the 4 over and it becomes takeaway. Right. Same for the next one. So the next initial condition was when t equals 0, dy by dt is 6, or y dashed 6. Means the same thing. I just try and keep the terminology the same throughout everything that we've been doing. So I'm going to be substituting these into this equation here. So 6 equals negative 2a e to the power of 0 plus be to the power of 0 take away 2b0 e to the power of 0 plus 12 cos 0 take away 12 sine 0. Okay, so 6 equals negative 2a plus b take away 0 plus 12 take away 0. Because again, same reason, the 0 here sends that part to 0. Sine of 0 is just 0. So 6 equals negative 2a plus b plus 12. So move the 12 across, so it becomes take away. So I've got that equation there. But luckily enough for me, I've already worked out what a is. A is negative 2. So negative 6 equals negative 2 to negative 2 plus b. So negative 6 equals 4 plus b. So b is equal to negative 10. So we're left finally with what we spent the whole time trying to do, and that is our particular solution. So we got our general solution back up, which was up here, top of the page. This is our general solution here. So that was y equals ae to the power of negative 2t plus bt e to the power of negative 2t plus 3 sin 4t plus 4 cos 4t. So there we have our general solution, but remember I've worked out that a is negative 2 and that b is negative 10. So y is equal to negative 2 e to the power of negative 2t, take away 10t e to the power of negative 2t plus 3 sin 4t plus 4 cos 4t. Okay, now as I've said, I've put the worksheet up on Microsoft Teams, but what I'll do is I'll quickly put it up on here for you to see. to leave the answer to that question up a little bit longer. So that's your final answer, and again, I would say that's probably worth about 16 marks, maybe actually more, maybe closer to 17 or 18 marks, right? The worksheet I've made up is this here. Okay, now I've put the answers up on Microsoft Teams. They're full work solutions with all the steps, and they're right, like that example where I got slightly wrong. But anyway, as you can see, 1's a kind of standard question that's worth 14 marks. 3's a slightly easier question that's worth 12 marks. And question 2 is really tricky. It's very similar to that second example I gave you there. Maybe not quite as bad, but it's very similar. So what I would want you guys to do is attempt all 3 of these questions by the end of this week. Tomorrow I'll be putting up a lecture on degeneracy, but that should be a much smaller lecture, and I'll only put a couple of questions up on that. So hope everyone's well, hope I didn't make too many mistakes, and enjoy the rest of your day.